Hello everyone. In today's class, we'll be studying about second lecture of highway pavement and materials. Right? Let's see what we'll study today. Today we'll be studying about soil stabilization principles, and methods of soil stabilizations. So first, we'll understand what is right. We'll understand what is soil stabilization today. Soil stabilization refers to the process of changing the soil properties to improve its strength and durability. Soil stabilization is a process of changing the soil properties. Now, what does it mean by changing its soil properties? We are going to add some materials to it or some chemicals to it, right? So, when you add some chemicals to it, it will react with the soil. So, when it reacts with the soil, there is going to be have a chemical reactions, and there is going to be change in the chemical properties and physical properties as well, right? So once it changes, that will improve its strength and durability. So what happens is some soils, we can't naturally available soils, we can't change its strength there itself, right? So what we'll do, we will mix some materials or some compounds into it, so that it that improves its strength and durability for our construction purposes. So now you might ask me where we are going to use it, right? So we are going to use it in the road works mostly, or in the case of huge structures where we want our soil to be have a good strength enough and have a durability or stability, you can say. We want our soil to be stable and should have a strength, right? So in that cases, in the case of roads, it is mainly roads where the soil is very much important, because the base or the subgrade that we talk about is the mainly what soil is available, we are going to improve its strength and stability, right? So that is where we are going to use this soil stabilization technique to improve the strength of the subgrade soil. What is subgrade? Subgrade is a lowermost layer of the flexible pavement and rigid pavement. Right? We'll come to that layers, different layers which are there in this coming lectures only. Right? Next is due to the stabilization. Okay, what will happen when we do this stabilization? Due to the stabilization, the shear strength, the capacity of taking load without deformation or cracking characteristics will be improved. So the we once we do the stabilization, what will happen? After once we do the stabilization, the strength, the shear strength, the load taking capacity, these characteristics will improve, okay, will enhance. Okay, we are trying to enhance the soil properties here. So obviously, the chemical as well as the physical properties of the soil will change. Next is soil stabilization is used in varieties of engineering works. For example, for construction of earth road and other cheap roads. It is not necessary that only for the normal or roads it is used. We try to the overall roads where it is very weak. The soil is very weak, and we can't change the replace the soil for that huge length of road, right? So of that region, whatever the region is there, that soil is there, so we can't replace it. So in that case, we are going to enhance it, right? That is what is soil stabilization is. Soil stabilization refers to adding chemical materials to improve and enhance the uh, and provide strength and durability and stability to the soil. So, what are the things or the what are the components of soil stabilization? As you can see, right? Obviously we need a soil. If there is no soil, then how can we do the stabilization, right? So when we add soil with a stabilizing agent or the chemical that we were speaking about, right? So what are those chemicals? We'll come to in the next slides. We'll see that. But now we say it as stabilizing agent. When you mix this two, right? When we mix these two, okay, when you mix it and consolidate it, we'll get a stabilized soil. What will you get? We'll get a stabilized soil. These are the components. That is soil, stabilizing agent, and the last, the product is stabilized soil, right? Soil stabilization principles. On what principles it works, right? Evaluating the properties of the given soil. First, we have to know whether the soil is good enough for our work, construction work, or not. Whether it is good or whether it is poor in its which properties. Whether it is poor in the shear strength capability, whether it has no stability, right? It has a low or high strength carrying capacity. So all these parameters, or whether it is a very absorbing absorbing nature of soil, so or whether it shrinks or contracts very easily, right? So all these things we have to first evaluate, right, by testing the soil. Once we test the soil, we will come to know what are its weaknesses and what are its strengths. So once we know that, we'll understand the chemical composition of that soil. Depending upon its weaknesses, we will try to add some chemicals that will improve specific properties that are weak, okay, that are not there in the soil. So this is how we try to do it, right? First we will evaluate the properties, right? We'll test the soil, then deciding the method of supplementing the lack of properties. What I said, first we test it, we'll see whether which properties are lacking behind. So depending upon that properties which are required, we add those required materials and required proportions to enhance those properties only. We're not going to alter the other properties, right? We are not going to alter the other properties. Deciding the method of supplementing the lack of properties by effective and economical methods of stabilization. It should be very effective. It should not that only once we mix this stabilizing agent to the soil, it only improves only 10% or 20%. It should minimum improve its strength capabilities or various properties by around 40 to 50%, right? It should improve its property by 50 to 40%, right? So that should be our aim, and it should be very economical, not very expensive one, because we require it for a larger length, for a larger area, because that soil might be in kilometers together, right? That soil may be available in along the road to the kilometers together. So we don't know that. So for that, it should be economical. Designing the stabilized soil mix for intended stability and durability values means what? For required stability and durability value, what durability and stability you want, depending upon that you are going to mix the soil and the stabilizing agent, right? You're not going to just improve more than you require, right? It is not necessary. You're going to construct such a road, okay, for that water stability and durability is required, okay. For that much only you are going to improve its strength and durability. You're going to mix the soil. Considering the construction procedures by adequate compacting the stabilized soil. Once it is done, we have to adequately compact the stabilized soil, right? Now, which are the different methods of soil stabilization, right? Mechanical soil stabilization. Correctly proportioned materials, when adequately compacted to get a mechanically stable layer, the method is known as mechanical soil stabilization. Now, in this method, we are not going to add any other material to it. We are just taking this soil, right? We are going to compact it adequately and efficiently, right? So that the layer becomes stable. Okay, nothing else. In the mechanical stabilization process, we are going to just compact the layer effectively such that it is stable. Right? Such method is called as economically mechanically soil stabilized. That method is called as mechanical soil stabilization. Next is right. Next is soil cement stabilization. In this method, we are going to mix this cementitious material. It not be a cement, but a cementitious material we are going to mix with the soil in a proportion, so that it's act like a binding material together. It binds the cementitious material will bind the soil together, and that will in turn will increase its uh, strength. Right. So we'll see what it says. The soil cement is intimate mix of soil cement and water. Soil cement is an intimate mix of soil cement and water which will be well compacted to form a strong base course. To form a strong base course. They might ask that in this sentence, uh, soil cement stabilization stabilized soil will be used where? It will be used in which layer? It will be used in base course. It will be used in the base course. Okay. Cement treated or cement modified soil refers to the compacted mix when cement is used in the small proportions to impart some strength or to modify the properties of soil. It is not added in large quantities, because if we add it in large quantities, this the rate or the cost will increase, right? And it is not of use. So we add it in very small quantities and to just modify these properties of this soil. Right. Next is soil lime stabilization process or method. We can say this process is very popular, and this is used a lot because lime is very cheap than cement. So we try to use lime in the most of the time, right? So soil limes are widely used either as a modified clayey soil, okay, as a modifier clayey soil, or as a binder in the fine grain soil. Where this is used, it is used in the fine grain soils. There can be a pozzolanic action resulting in adding a strength. So lime also has some cementitious material because and also has pozzolanic actions, right? It is a pozzolanic material, right? So we have seen these lime mortars. Why lime is used? It is a binding material, right? So in the same way, we're going to mix the soil, lime, and water, and we are going to compact it properly so that we get a stability and we modify it. And we mostly use this lime stabilization process in the fine grain soils. Okay. Next is soil bitumen. Soil bitumen stabilization. Here also it is the same thing. We're going to mix this bitumen with this soil, right? And we're going to compact it. This soil, the basic principle in using the bituminous stabilization are waterproofing and binding. By waterproofing, the inert strength and other properties of the soil could be retained. In this method of soil and bitumen, we know that bitumen and water are repellent. They don't. It is not a good absorbent. It is a repellent. So they are not. They are unlike forces. When they come together, they try to move away from each other. So same thing that is used wherever we want our soil. It has a good strength, but if it comes in the contact with water, it will change its properties, some properties. So we don't want that water to come in contact with the soil. So at that time, what we do, we mix bitumen with the soil. so that the water, it becomes a water repellent soil, so that the properties are not changed, right? In not all the cases, but in some cases where the it is very adhered to the water, where it is sensitive to water. When the soil is very sensitive to water, we mix the bitumen, so that we get a retain the strength what is there in it, and it becomes a waterproofing inert material, right? These were the some of the soil stabilization. This was about soil stabilization. What is soil stabilization? What are the things that we see in the soil stabilization process? Which are the various methods and its principles, right? This is about all about soil stabilization.